All right, good afternoon, everyone. Thank you for attending the IECC 2021 for Mechanical and Plumbing webinar today. This webinar will be recorded, and the recording will be sent out to all attendees. It's in that Google Drive link that's in the follow-up email. If there are any issues with audio, my name is Erica DeLello, and I'm a project manager for Noresco. Just write me in the chat, and we'll get things sorted out for you. This series is sponsored by the Colorado Energy Office with training materials provided by Noresco. So Kevin and I have been working with the Colorado Energy Office to provide trainings just like this one. Here we have a list of the trainings offered over the next couple months. And there's always a registration link if you want to sign up for any others. And we're also going to be meeting soon to add a few more to this list. So keep an eye out for an email from me. And then in addition to these webinars, this webinar series, we also provide tailored trainings for groups or technical assistance for jurisdictions that are updating I-codes. And then we've put together a code adoption toolkit, which probably populated for you when you entered this meeting. And that reviews the cost implications of changing code cycles, benefits, and a lot of other compliance resources for jurisdictions and industry professionals. There's also a troubleshooting guide that covers I-code conflicts, alignments, clarifications, and passive compliance. Both of these resources can be accessed through the Colorado Energy Office's website. So throughout the webinar, we do want to encourage questions. If you could please use the Q&A function. I'll let our presenter know at the end. The chat window can also be used to chat among participants, but please use the Q&A if you'd like to ask a question. And then there's also the opportunity at the end to raise your hand, and I can go ahead and unmute you and you can ask Kevin directly. Lastly, there will be a survey window that pops up following the webinar. Please take a minute to provide that feedback so we can continue to improve on these webinars. So today's presenter is Kevin Perry. Kevin is a certified commissioning professional with a decade of experience. He's provided over 100 trainings, maybe even more than that now, Kevin. We've added to the list for sure, but he's provided trainings to contractors, architects, engineers, and code officials, and he's a certified plans examiner and inspector for IECC and ASHRAE. So without further ado, I'll stop sharing my screen, Kevin, and you can go ahead and share yours.
All right, great. Thanks, Erica.
Yeah.
And let me know if I have the right screen.
Yep, you're good to go.
Okay, great. So thanks everybody for joining, and thank you, Erica, for hosting this. Like Erica mentioned, today we're going to talk about the changes in the IECC from 2021 back to 2018. So everything that's changed in the mechanical section and the service water heating section, also known as plumbing section. From 2018 to 2021, any significant changes in those two sections we'll go over today. Make sure my slides are moving. Erica already covered all this. So today's learning objectives is to discover, like I said, discover those changes. And these are the sections that we're going to discuss, 403 and 404. So if you have, you might be here because you haven't been able to access or get a copy of this book yet. So thanks for joining. I don't even have a copy of the book yet. I don't know if they've actually been printed and mailed out yet, but they do have a copy online for free, which is where most of this content has come from. But this is a first glance for some of you on the 2021 code changes. So let's start off with a few definitions that have changed. in the new code cycle. They have updated some of the terminology for the mechanical sections. I kind of pulled out the ones that pertain to mechanical. Obviously, there's some other ones that have changed as well, but we won't go through every single one of these, but just know that they added some new definitions because the way that they were worded before didn't necessarily, or I guess I should say, allowed for some gray areas on whether or not certain items needed to follow this code or not. So they're trying to close those gray areas up on that. So for example, data center systems is defined as HVAC systems and equipment or portions thereof used to provide cooling or ventilation in a data center. So that's data center systems. But they also added data center, which is a room or series of rooms that share data center systems whose primary function is to house equipment for the processing and storage of electronic data, and that has a design total ITE equipment power density exceeding 20 watts per square foot, and the equipment load greater than 10 kilowatts. So it's getting a little bit more specific. So you could technically have, by this definition, a data center located within your building that's maybe a office space. So just know that some of these definitions have kind of put us into categories that we would need to know these definitions or follow now because of that. And then they've also have revised some definitions. This is one of them, just called out. Demand recirculation water system is one that they revised to update to make it a little bit more rounded on that. So now it says demand circulation water system is a water distribution system where one or more pumps prime the service water piping with heated water upon a demand for hot water. So I won't bore you with reading any more definitions. That's not why you're here, but wanted to give you some background because you might see some of these definitions throughout the presentation. Okay, so let's go to data center. Let me see if I can get my notes up here. Hopefully, bear with me one second. Sorry about this. Of course, there's always going to be some kind of technical difficulty nowadays with everything being virtual. So appreciate you sticking there with me for a minute.
All good, Kevin. This is also Kevin's first time using the Zoom webinar platform. So, right?
I'm getting there. Okay, so in general, general systems on the mechanical side of things, they've updated the data centers for in the general category. And really what that is saying is basically what they put in there is an exception. Data centers are now exempt from the requirements in sections 403.4 and 403.5, which I don't expect you to know what those sections are, but really what that is controls, so the control section and the economizer section. So if you now have a data center, remember that new definition for data center, they don't have to follow the control section or the economizer section just for that data center portion. So if your building's a complete data center, that's fine, but if you have a portion of your building that's a data center by the new definition, then that portion wouldn't have to follow those two sections. However, the rest of the building still would have to follow that. So data centers do have to follow the ASHRAE 90.4 section for mechanical load components. And really that's for the power required for cooling, fans, pumps, heat rejection, things like that. So data centers go to ASHRAE 90.4 to see how those are supposed to be designed now for the IECC portion of the code. So IECC is referencing ASHRAE. Okay, next slide is fault detection diagnostics. You might recall that as a familiar name in the last two code cycles, or at least the last code cycle. It was called economizer fault detection diagnostics. Now they have dropped the fault detection or the economizer part of that and said fault detection diagnostics. And really that's basically saying that not only equipment, mechanical equipment that has economizers on it need this, but all HVAC systems serving over 100,000 square feet need to be capable of having fault detection and diagnostics. So that's a pretty big change from the previous code section where only economizer equipment needed that. And so you might ask what that means. Well, it needs to be able to monitor the HVAC performance and sampling the system's performance at least every 15 minutes, every interval of 15 minutes or more. So like if you wanted to pick 5-minute intervals, that's completely fine too. But you need to do it at least every 15 minutes. Then it needs to automatically identify and report any system faults, and then notify any authorized personnel of those faults. And it's not just at the building automation system level anymore. They're actually saying that, you know, all the times that I go into, a lot of times when I go into buildings and look at the building automation system, there's always this little red bell kind of chiming in the corner. And I always pull that up to see what that is. That's the alarm list. That's, you know, the notification system that something's not right. Well, we've come to a point where we now have over enunciated the amount of alarms, and so those tend to get ignored. So what the code has said we're going to do is not only do you do that on the local level, but you also must be capable of transmitting that that fault to somebody located remotely. So sending a text message, sending an email, something of that nature has to be part of this fault detection and diagnostic system. So it's getting kind of a little bit more in your face, if you will, on what is required on this, but it's really trying to catch the attention of people to address these items in a timely manner instead of just letting them carry on down the road until they get to it. And I will say that the last thing that it has to be capable of doing is prioritizing recommendations for that fault. So not only does it have to notify and report, identify the fault, but it also has to identify based on the data collected from the HVAC system, you know, that every 15-minute interval, it has to prioritize and come up with recommendations for repair on that fault. So that's quite a bit there. Not too many building automation systems do that automatically. They will, however, a lot of them will give you notifications and then also give you the ability to send somebody a text message or email or something like that. but to come up with the recommendation and prioritize those is not something that is too common out there currently for building automation systems. So what does this mean? This means that maybe the code is starting to push towards analytical systems. There are several out there that have been around for a few years now. They're becoming more and more, but these building analytics are becoming more and more popular because they basically do the hard work for you. You don't actually need a human to tell you that a potential sequence or system is running wild. You can, why not have a computer tell us that, so we don't have to dig deep through that. So this is a big change. All HVAC systems serving over 100,000 square feet need to have some type of building analytics, I'll say, for a lack of better term, but if you want to follow a definition, fault detection and diagnostics. Okay, next slide is HVAC equipment performance requirements. So this section, if you recall, and if you open up the code book, or if you ever have opened up any code book, there's always tons and tons of tables in there. So that's what this section is about. So the performance requirements have been updated for the systems listed here on the slide. So if you look at furnaces or boilers or water chilling packages, air-cooled heat pumps, those tables have been updated in the code, in the new 2021 version of the code. I will spare you the thrill of posting all those and going through all those, but I did put a snippet on the screen there. I know it's kind of hard to read, but just to show you that some of these categories of systems, the efficiencies have increased, or some sort of item in that table has changed in the 2021 code, which is expected. You know that we can't get towards our energy efficiency goals if we don't increase efficiencies on some of our equipment. So I don't think it's too crazy, but I will say that from what I can tell, that these tables now are closely in line to the ASHRAE 90.1 tables. So if you're familiar with ASHRAE 90.1 and their efficiency requirements in their tables, IECC is now starting to line up the tables in these sections closer to that ASHRAE to 90.1. So another new update in the 2021 code cycle has to do with supplementary heat on heat pump systems. So what they've said is that when your heat pump has the ability to provide supplementary heat, it can only happen when one of the following is happening. So the vapor compression cycle basically can't satisfy the thermostat, can't keep up with the space temperature. Then you can use your supplementary heat. If the defrost mode, if it's in defrost mode, it can then use supplementary heat. Or when it malfunctions, so when the heat pump malfunctions based on the vapor compression cycle, or based on a malfunction from the thermostat, then you can use the supplemental heat from your heat pump system. Other than that, your supplemental heat cannot be used according to the 2021 code cycle. So that's kind of a new, that's kind of a big jump there on that. And from my understanding, this would be something probably programmed from the factory, but could potentially be programmed from the BAS, Building Automation System side as well, but it's probably a lot easier to achieve from the factory, coming from the factory. Another new addition, modification, if you will, in the 2021 mechanical section. If you recall, in 2018, they had this automatic start for your mechanical systems, AKA morning warm up or morning cool down. That was introduced in 2018, that your mechanical systems need to have this auto start. Well, in 2021, they've added it now needs to have an auto stop. So what that means is basically as your building becomes unoccupied, so you have an occupied schedule and an unoccupied schedule. So as your building occupancy schedule gets closer and closer to the unoccupied time, so say your building's set up to be occupied from 8 a.m. to 5 p.m., and then at 5 p.m., the thermostat set back to maybe 80 degrees and 60 degrees, something like that. So as it gets closer to 5 o'clock, what needs to happen is you need to start to reduce your occupied set point by 2 degrees or more, so that by the time it comes to unoccupied schedule, it's already starting to basically wind down or drift into that. So systems that have DDC controls and individual zones need to follow this. So any HVAC system with individual zones need to, based on thermal lag and acceptable drift, it's got to stay comfortable in that space. It's going to start to set back the occupied set point by at least 2 degrees based on those calculations. I know that there's one building in downtown Denver that I regularly have meetings in, and it does exactly that. And this isn't a new building by any means, but come 4:45, you can tell the HVAC system is turned off because the fan, all the noise, the kind of the low humming of the fans throughout the day has now shut off and is letting the temperature drift for the last 15 minutes of the day on that. So that is something new, this automatic stop that needs to be incorporated. Okay, heat rejection. So hydronic water loop heat pump systems, they've added a section to this. They added a closed circuit cooling tower to the requirements for this section. So before it was just an open circuit cooling tower. Now closed circuit cooling towers have to follow this heat rejection system in that. So when they're used in conjunction with a separate heat exchanger to isolate the open circuit cooling tower from the heat pump loop. Again, just added definition or added just a slight thing to it that you're probably already familiar with. Okay, 2 position valves. So with this section, hydraulic heat pumps over 10 horsepower have to have these 2 position valves now. And what that is basically that the automatic valves shall be interlocked to shut off the water flow when the compressor is off. So it needs to be automatic and interlocked. Probably not a big thing, but it might add a little bit of cost to the project, but this is good practice anyway. So now we move to economizers. Economizers was a big section and a big jump from the 2015 code. And then even the 2018 code, they made some modifications. And now in the 2021 code, they made even more modifications. So in 2015, if you recall, they said that basically any system, any mechanical system needed to have some sort of economizer mode. There were some exceptions. 2018, they then went back a step and said, well, not everything needs to have an economizer that's mechanical. And then in the 2021, the current code, they went back a little bit more as well and added another exemption saying that VRF systems, variable refrigerant flow systems, installed with a dedicated outdoor air system are now exempt from the economizer section. So it's another exemption added to the list. So I think they went pedal to the metal in 2015, released a little bit in 2018, and starting to release a little bit more in 2021. Okay, demand control ventilation. Demand control ventilation is a hot topic right now. If you all have been following ASHRAE's guidelines and the CDC's guidelines with infectious disease prevention and control right now, they talk about demand control ventilation and turning that off temporarily until we get through this pandemic. So it's kind of a hot topic right now. And the reason for that is that they want more outside air. They want you to open up and basically lock the outside air to have more air changes per hour, and then instead of using your demand control ventilation for right now. So let's flash back into 2021 code cycle demand control ventilation, when is it needed according to the cycle or to this code cycle? So all single zone systems that have an economizer, so remember that section of economizer that we talked about previously, quite a few systems were required. If it's a single zone system and it has economizer, they are now required to have demand control ventilation. Also, any spaces larger than 500 square feet, and they have occupants on average of 15 occupants per 1,000 square feet would require demand control ventilation. So that's not new. What's new on that part is the occupants. So it used to be on average a 25 occupants per 1,000 square feet. They've reduced that to say 15 occupants per 1,000 square feet. So when you're designing things, that number is going to be a new number to follow. So if you fall into either of these categories and you need demand control ventilation, they have some exceptions here. If you have a multi-zone system that's less than 750 CFM of outside air, then you're exempt from this demand control ventilation. That used to be, that 750 CFM used to be 1,200 CFM. So getting a little bit tighter, tightening the belt a little bit there. If you have makeup air or transfer air systems, that would be an exception for not needing demand control ventilation if that's what your equipment is used for. And then based on occupancy type. And what that means is basically they put a list together of occupancy types that don't necessarily need demand controlled ventilation in their eyes, and what those space types are. would be correctional cells, education labs, barbershops, salons, not saloons, salons, sorry, and bowling alley seating areas. So they've added those as exceptions to this section. And then the ventilation process loads is an exception. It has an asterisk next to that, but there is a exception based on your process loads. Okay, parking garages. They do have mechanical systems in there. With those mechanical systems, what we're used to is ventilation. Right now, it's just carbon monoxide detectors in there that trigger our exhaust fans and things like that to come on. Right now, in 2021 code cycle, they're saying that they need enclosed parking garages, need to have carbon monoxide detectors in conjunction with nitrogen dioxide detectors. And so that's what's going to trigger, those two things are what's going to trigger the exhaust systems to come on in enclosed parking garages. Now there are some exceptions just with every rule and thing in the code. The exceptions is if the total exhaust capacity is less than 8,000 CFM, then you're exempt. The old code had a much larger number of that for an exemption. So the old code said like 22,000 or 23,000 roughly CFM. So if your exhaust was less than 22,500 CFM, you didn't need to have this interlock with your exhaust fans. Now what they said is if it's 8,000 or less, you don't. So anything above 8,000 CFM, it needs to be interlocked. Energy recovery systems, they split this up into, there's a lot of changes from, if you look online, usually the blue text is how they differentiate the changes in the code. And there's pages, page or two of blue text here. But in reality, they just broke it down into two sections. So you need a energy recovery system, and they would say, all right, if you have a non-transient dwelling unit, and then everything else. And so really that's how they broke it down, is saying, all right, if it's non-transient dwelling unit, you need to have outside air energy recovery with an enthalpy ratio of 50, based on your climate condition. There's this whole chart there on that. So basically you got to look at your space type. Is it a non-transient dwelling unit, or is it something else? If it's something else, then you would follow the specifications in the tables. And again, looking through the code book, these tables don't appear to have changed their values. The thing that has changed in this system, in this energy recovery section, is the definition of non-transient dwelling unit and then other spaces. Okay, temperature set point and controls for guest rooms. So this would be like hotels. So if you're working on a hotel project, you have temperature controls. We basically had a blanket statement before saying, all right, the HVAC system has to be tied into the occupancy sensor, and it has to do such and such. That was the old code. Now, for these guest rooms or hotel rooms, it's basically splitting up what controls have to do based on 3 different categories. So if the space is rented, but it's not occupied, it needs to raise / lower the set point automatically by at least 4 degrees 30 minutes after it becomes unoccupied. So basically it's saying you're in an occupied situation, it's, you know, but nobody's actually in the space. All right, so it's rented out. We know people are going to be using it in the next, you know, they rented it out for 3 days. Well, we don't need the HVAC system on 24/7 for those 3 days. So when they're not using the space, when they're not in the space, 30 minutes after they leave, it's going to go into a temporary unoccupied setback. And that needs to be at least 4 degrees. And then you have a category of unrented and unoccupied, which to me is basically just saying it's not being used. But anyway, they made that category, and that's saying that the temperature will be set back between 60 and 80. And then you have the occupied set point, which anybody want to take a guess on what that means? It's pretty straightforward, right? Somebody's in the space. And when they're in the space, it's going to be running at the occupied set points. One thing I'll pause for right there is that occupied category. If you think about it, it seems a little silly that there has to be a program that says an occupied set point. Usually, every time I've gone to a hotel room, you can adjust it, the thermostat, to whatever setting you want while you're in the space. I think what they're hinting at here is that they want the BAS to limit what the occupant can control the space temperature to while they're in the space. It doesn't explicitly say that, but I think they're hinting at that, and who knows, maybe in the next code cycle that is going to be in there. But right now, it's just saying that in occupied mode, it goes to occupied set points. All right, motor nameplate horsepower. They basically, this isn't new, if you're familiar with this, but they added 2 exemptions. Exemption 1 is for fans equipped with electronic speed control devices. And then exception 2 are for fans less than 0.89 kilowatts of power. So you still have to follow the motor nameplate horsepower requirements for your motors, but if they're equipped or with the speed control or draw less power, then they're exempt from having to follow that 1.5 times the fan brake horsepower or the 1.3 times fan brake horsepower. Fan efficiencies, you know, nothing crazy here. Used to be 0.67 or greater for fan efficiency grade. Now it's 0.10 or greater. And they also added a section for fan arrays. So if you have a fan array, your fan efficiency grade has to be 0.95 or greater. And there is a slew of exceptions in here. I think there's like a dozen of them. So just know that you could be exempt on some of these. Low capacity ventilation fans. I look at this as like maybe bath fans. So fans that are basically less than a 12 horsepower now have to follow this table. If you're familiar with the City and County of Denver amendments from last year, this is the exact same table that they adopted. So if you're familiar with that, nothing has changed. If you're not familiar with that, I would say get familiar with this table because now you have minimum efficiencies on these low capacity fans. Now there are exceptions. If fans are components of the listed heating or cooling appliance or a dryer exhaust or domestic, kitchen range hood, those would be exempt from this. And the last thing we'll talk about in the mechanical section here are large diameter ceiling fans. So I'm sure we have all seen these big fans, but really any fan 7 feet in diameter or bigger, that's what it's saying, have to be tested and labeled according to the AMCA 230. Is that a big deal? Probably not, but just know they're now starting to require that. Okay, so I'll pause right here. Erica, I'm going to pause here and see if anybody has any questions at this point before we go into the domestic water section.
Okay, yeah, if anyone has any questions and wants to write in on the Q&A, feel free to do so. We'll give it another minute, Kevin, but as of right now, we do not have any incoming questions.
Okay, well, from then I guess we'll continue with the presentation. So want to make sure that I have the right screen again.
Yep, looks good.
Okay, great. So service water heating, not a whole lot has changed in that section. So this is very quick, I think only 3 or 4 slides, and we'll get into it. So 2021 has changed that service water heating efficiency for high input heating. So water heaters that are high input, so that's above 1 million BTU per hour, now require an efficiency of 92. And this is new to the 2021 code cycle, but as you can see from this chart, if you're familiar with the city and county of Denver, they actually adopted this the previous year. So if you're outside of the city and county of Denver and other parts of the state, then this would be new. And it wasn't a big change. It went from 90 to 92% AFUE. And then the next slide is about water volume determination. This is one of those slides or one of these areas that's always catches me a little bit by surprise, but there's a couple ways that you could determine your pipe volume or pipe length, I should say, based on your pipe size. So from generation to source, there was 2 ways to calculate what length you could have or how much volume could go through there. So the old code is this top table, and you'll see if you had a 1-inch pipe, if you did it via volume, you're allowed 5 liquid ounces per foot of length. If you did it via just straight up pipe length from generation to source for a public lavatory faucet, you were only allowed a 1/2 foot of length from generation to source. So that was the old way of doing it. What they did is they still kept this in there, but they added a caveat, a little bit more definition for the volume. So if you're doing it via the volume way, they've added this table down here. So this is now the table for volume, and you can see if we follow that still same 1-inch size, pipe size, it's dependent on what type of material that pipe is made out of, on how many ounces per foot that you're allowed to have now. So if you use copper type M, you are now allowed a little bit more than the 5 before, but if you look at, if you use CPVC, then you're a little bit below that, especially Schedule 80. So just keep that in mind. I don't know how many people are using the volume method versus the pipe length method, but if you're following the volume method, that has been updated, hopefully in your favor in the new code cycle. Okay, and then the last thing for surface water heating, I know that was a long section here, is that they came up with some new things for circulating systems. So all systems need to be circulating systems, or sorry, not all systems are circulating systems, but they split this up into demand circulating systems, and then all other systems. So the controls shall limit the temperature of entering cold water to not be greater than 104 degrees. So for all circulating systems, you have to have some type of control set up that the entering water, so basically the water coming back to the heater, can't be more than 104 degrees. I see some potential issues with that, but it's not my place to go into that during this conversation, but there could be some workarounds here that are not great for energy efficiency. And then the pump needs to be turned off when the desired temp loop has reached the desired temperature. So basically, if you're trying to have a 130 degree loop temp and there is no demand for water, then that circulation pump needs to turn off. And this is something that I don't see typically when I'm out in the field. Usually these little recirculation pumps like you see on the screen here are running 24/7, constantly and just nonstop. So what this means is that controls is now going to be needed to program and monitor these domestic water pumps and loops in the new code cycle. So with that, that will conclude both the mechanical and service water heating sections. I'll turn it back over to you, Erica.
Thanks, Kevin. We do have some questions for you. And just to start, I want to point out, Kevin mentioned that you can access the iCodes for free online. It's not downloadable, but I use it for reference all the time. And I put the link in an answered question, so feel free to check that out. So Kevin, the first question we have is regarding the new data center exemption that was mentioned early in the presentation. Would small unoccupied shelters that house monitoring equipment qualify as a data center? This monitoring equipment runs continuously and generates heat that keeps the shelter warm, so no additional heating is required for the shelter, only cooling to keep the room at the appropriate temperature.
That's a great question, and actually a really cool way to do things, right? These data centers are providing, or basically in your case are providing heat for other spaces without, instead of just wasting that heat and ventilating it out and whatnot. I would like to think that would be an exemption because you're reusing that waste heat and such, but I don't know. The code does not specifically call out that exact example as an exemption for data centers.
Okay, thanks, Kevin. I feel like I remember looking and there's like certain watts per square foot that you need to meet to be qualified as a data center, or something along those lines, but check back at that.
Yeah, so there is in the definition, so the new definition, so I guess that's a good point. In the new definition of data center, I'm trying to pull it up here. I think it's 10 kW. No, that's too small. Let me see if I can find it real quick.
Yeah, no problem.
Definitions and data center. Okay. Data centers are power density exceeding 20 watts per square foot. So I guess if you have a low power system, then a small space, then technically that you could then be exempt from that. So great question.
Okay, and we've got another question here. How does one meet the pipe water volume requirements on a PEX home run domestic water system?
Yeah, good question. I don't know if the code actually calls out PEX, because as you saw in the presentation, in that the code book has different pipe materials, but PEX, there is PEX schedule 9. So I guess it just depends if that's the type of PEX you're using. I'm not familiar with all the different types of PEX, but there is a PEX category. It's the last one in that chart. Let me see if I can pull it up. Maybe that'll help. But other than that, I don't know how you would follow that. Let's see if I can, I don't know how I can share my screen again.
You should.
Let's do screen 2. So you could see, can you see my screen with the chart on it?
Yep.
So this last category does show PEX, but I don't know if that's the specific PEX that you're asking about on that.
Okay, thanks, Kevin. I think those are all the questions that we have today. Kevin and I will stay on the line for another minute or two if any other questions do come up, or if someone wants to raise their hand, feel free to do so. But otherwise, thank you everyone for attending today, and we hope to see you next week at the architectural updates for IECC 2021. And Kevin, thanks again.
Thank you.